One of the challenges of climate change research is to try to take the information from climate models and use them to make predictions for food crops in the future. Now, there's many aspects of this. One of the things that's going to change under climate change is the temperature. It's going to get warmer, and warm temperatures may become more variable. The other thing is the rainfall changes. Rainfall may get heavier in some parts of the world, or it may get drier in others. And what we need to do in the Walker Institute is to try to assess how these changes will affect the productivity of our food crops. So how much yield we get each year, how much profit farmers and agribusinesses will make from one year to another, and how available food supplies are in nations where perhaps there's a risk of famine. One really important feature of climate change is how the variability of climate may alter. In other words, will these really hot days become more frequent? Will these really dry periods become longer and more frequent? These are really important for crops. These are really important for a number of reasons. First of all, the impacts of short episodes of hot temperature at certain stages of crop growth can be very dramatic. The climate scientists struggle with these very short-term temperature extremes. Trying to forecast these using models is extremely difficult. And if you're a farmer planning ahead, it is extremely difficult to try to judge whether or not to risk planting another variety instead of your normal variety on the hope that you may miss an infrequent high temperature event. So the big challenge for us at Reading then is, how do we forecast the impact of climate change on crops? What tools do we have? Well, what we have is we have mathematical models of how crops grow, develop and form their seed. And these are called crop simulation models. These are, in a sense, virtual crops. These are crop models that live within our computers and forecast the effects of climate change and other factors on crop growth and yield. So we take the information that our climate scientists within the Walker Institute provide, and we use that as an input into our crop simulation models, and we run these out for forecasts maybe 10 years ahead, 30 years ahead, or even 50 years ahead, and look at the impact of future changes in climate on crop yield, on the quantity of food that an area will produce. Now, this tells us a number of things. This can isolate areas which are particularly vulnerable to climate change, and examples there will be the drier parts of India, the drier parts of Africa, and some parts of China. It can also tell us where areas are that will benefit from climate change, where there be opportunities to agricultural producers. The northern parts of Europe are one, perhaps some parts of Russia and the Ukraine are another, where a moderate amount of warming will benefit crop producers. Now, the next question then is, how can agriculture adapt? How can agriculture adapt to offset some of these negative effects? Or how can agriculture take opportunities in some parts of the world that will arise under climate change? Well, there's a number of ways. In the short term, farmers can change varieties, they can change their sowing dates, and they can alter their management practices to respond to short-term changes in climate. Now, in the longer term, there's more investment needed, and these are really important changes. Substantial investment to farming systems, to the infrastructure of farming systems, to the modification of crops themselves is going to be required over the coming 1, 2, 3 decades. Now, all these changes will require substantial investment, and it's really important that us as research scientists are able to inform those investment decisions. Here at Reading, we have the facilities to screen, to assess how different varieties or genotypes of crops are affected by these extreme weather conditions. And we can select those varieties of wheat, of soybean, of maize that are more tolerant to these extreme conditions, and we can suggest then to the crop breeding community internationally that they perhaps should be incorporating these new varieties within their breeding programs.